Welcome again to today's class. This day we want to discuss partial fractions. So this video will be in many parts. So this is the introduction part of it. So keep in touch with the video by clicking subscribe and like. So as the subscribe you click will make it possible that you get notified as we upload other part of this video. Back to the topic, partial fractions. What are partial fractions, or what is partial fraction? Partial fraction is simply defined as sum of simpler fraction of a rational or compound fraction. I repeat, partial fraction is simply defined as sum of simpler fraction of a rational or compound fraction. It is meant, or every partial fraction should be in proper form. That is, the highest power of the numerator must be less than the highest power of the denominator. Once the highest power of the numerator is greater than the one in the denominator, please use long division method and divide before resolving to partial fraction. The nature of the denominator determines the type of way you can resolve your partial fraction, or will determine the result of your partial fraction after being resolved. See what we mean. If the denominator have non-repeated factors, if it has non-repeated factors, denominators with non-repeated factors, e.g., they give you 3x minus 1 all over 2x minus 3x minus 5. You can see that they are factors, non-repeated linear factors. Let's put it this way. Non-repeated linear factors. So if you have it this way, you resolve it by saying a over 2s minus 3 plus b over s minus 5. That will be the resolved answer to this. So what if it can also be in this form, assuming they said given that 5x plus 1 all over s bracket s minus 2. You resolve it this way as a over x plus b over x minus 2. They are under denominators, partial fractions with denominators, that are non-repeated, or with denominators with non-repeated linear factors. So this is denominators with non-repeated linear factors in partial fraction. This is how it look like. Now, remember the numbers we put here can be changed, so they are not constant. Then when you have repeated factors, what do we mean? Denominators with repeated factors. Repeated factors. You have something like this, okay, let's put it this way, repeated linear factors. Say that the answer will be, take for instance, they say 3s plus 4 all over s plus 5 raised to the power of 3. You can see the denominator is repeated. It has power of 3. You resolve this way, a over s plus 5 plus b over s plus 5 raised to the power of 2 plus c over s plus 5 raised to the power of 3. That is typical way you can resolve it. What if it has linear and repeated linear factor? What if it has linear and repeated linear factor? That is 3 denominators with linear and repeated linear factors. denominators with linear factor and repeated linear factor. Say you put it this way. Take for instance, they say 3x minus 2 all over 2x minus 3 and x minus 1 all raised to the power of 3. Put it this way. A all over, say that there is partial fractions of it to be a all over 2x minus 3 plus b all over x minus 1 plus c all over x minus 1 raised to the power of 2 plus d all over x minus 1 raised to the power of 3. So that is how you can resolve it. Then what if we have partial fraction that their denominators is linear plus, what if we have denominators that are denominators with denominators that are unfactorizable quadratic denominators with unfactorizable quadratic factors. Say the answer will be, take for instance x minus 1 all over x squared plus 5. You know that x squared plus 5 is a quadratic expression, but you cannot factorize it. You can't factorize it. So you now say the answer will be ax plus b. Because you cannot factorize, you put this s to one of the alphabet all over x squared plus 5. Then, what if we have denominators with linear and non-factorizable quadratic factors? Denominator with linear factor and unfactorizable quadratic factor. E.g., we have, let's say, x minus 1 all over x minus 5 all over x plus 1 and x minus 2 raised to the power of 3. Okay, unfactorizable linear factor, x squared plus 3. This quadratic factor, this quadratic expression, you cannot factorize it. Try to factorize it on your own. You see you can't factorize it. You say it will be a all over s plus 1 plus b s plus c. We are attaching s to this all over s squared plus 3. That is how you resolve it. Then what if we have repeated factor and unfactorizable quadratic factor? Denominator with repeated factor and unfactorizable quadratic factor. E.g., x minus 5, then x plus 1 raised to the power of 2, x squared plus 3. Look at how you resolve it. A all over s plus 1 plus b all over s plus 1 raised to the power of 2 plus c x plus g all over x squared plus 3. So that is how you package it. What if the denominator has improper fraction? What if the denominator, when the highest power, when highest power of the denominator is less than the highest power of the numerator. When we have such, we call it partial fraction with improper fraction. We call it partial fraction. We call it partial fraction with improper compound fraction. So when you have this, when you have improper compound fraction, the implication is that you must divide it using long division method so that to reduce it to proper aspect. Take for instance, they say x raised to the power of 3, e.g. x raised to the power of 3 all over s plus 1, s minus 3. You have it this way. If you are to do it, expand this. If you expand this, you'll be having, if you expand this, you'll be having x squared. This times this minus 3x plus x minus 3. So that will be giving us minus 2s minus 3. We say we'll be having minus 2s minus 3. We put it this way. Then it's dividing s raised to the power of 3. S squared divide s squared. You have s squared divide s cubed. You have x. S times this. S times this. S cubed. S times this minus 2x squared. S times this minus 3x. You put minus. This minus you are putting is a mod. This subtract this. Minus times this will be giving us 2x. Minus times this will be giving us plus 3x. Then we now say this will be what will remain. Minus times this 2s squared. Minus times this plus 3x. So s squared divide 2s squared. You have plus 2. 2 times this 2s squared. 2 times this minus 4x. 2 times this minus 6. So this minus this, it will go 3s minus times minus plus 3s plus this, that will be giving you 7x minus times is plus 6. So we say therefore we have x plus 2 as our answer plus 7x plus 6 as what remain all over x squared minus 2x minus 3. So that is what we write. X plus 2, we write it different. Then say that what we are to resolve is 7x plus 6 all over s plus 1, s minus 3. Because this will still give you this. Okay? So these are ways you can remember we said the nature of partial fraction you will have depends on the nature of their denominators. So look at the nature of denominators we can have. Denominators with non-repeated linear factors, with repeated linear factors, with linear factor and repeated linear factor, and so on. There are three ways you can solve or you can use, or three methods you can use to resolve partial fractions. One of the methods is called cover-up method. One, cover up. Two, direct substitution. And three is comparing their coefficients. So these are the three possible ways one can use to resolve a given partial fraction, into its partial fraction. So these are three possible ways you can use to resolve it. Thanks for watching the video. Please, in the next video you will see how, or you see some questions we will need to solve on partial fractions. Please don't forget to click subscribe. Please just click subscribe. It will not cost you anything. Then like the video as you enjoy it. See you as we solve the questions on partial fractions.